Moving right along, today we're going to start chapter 12. But before we can go anywhere in chapter 12, I want to take a quick look back to chapter 5. And in chapter 5 was when we were doing work with files. Some of the basics of what was going on in chapter 5. When I was working with a file, I had to do an pound include fstring. Little preprocessor directive to let us know to include that. And then, for example, if I wanted to get a file ready to open up to write to, I did the OF stream for an output file. And then I did output file, the file name, .open, so that I knew what. So basically, I created the file name that I'm going to use in the program. I would read it in or whatever, and then I would make sure that I closed the file. Okay, one way of reading in was input file, and it would store a name. One way to read in a whole bunch of numbers was by using a while loop. File name greater than, it stored it in there and let me keep working until it got to the end. So does any of that sound familiar from chapter 5? Again, we were using OF stream for output. We used IF stream for input, all from the F stream class. Good, nothing new so far today. Okay, so today we're going to take a look at chapter 12. And instead of using IF stream and OF stream for file operations, and again, this was dedicated to input, this was dedicated to output. But if instead of those, I just decide to use F stream, I'm going to be able to use it for possible input or output. And the way I'm going to determine that is I'm going to use these things called access flags. Okay, iOS append, iOS in, iOS out. For example, you did code listing 12.1, okay, and you saw an example of this inside of there. We have my include statement. I create F stream, file name, data file, my object. I take my object, I do open it, the file name, and then I'm going to open it for output. Now you're thinking, well, why can't we just use what we did before? Just real quick, I work with it, and then the last thing I always want to do is close it. But I start to hit these file access flags that you see down in table 12.2. And this is where I can start to change it. I could do the basic output or input, but I have some other options. Okay, append is one that might be common, where I'm going to append something to the end of a file. That way, if I get ready and I wanted to open it to write to it, in the old days, it opened it. If it didn't exist, it created it, but it also cleaned out what was there. And I don't always want to do that. When I get ready to send stuff to an output file, I might want to append to it. And you see that here's our input and output, and there's a couple of other basic ones that are included here. Okay, so now I'm going to be able to use these file access flags to do multiple things. You did type in code listing 12.12. You typed in another example, code listing 12.2. My camera's not working. There we go. Code listing 12.2. We created the data file. Okay. We linked it up with demo file to open it. We're opening it for output. We write Jones and Smith. Okay. We close it. Then we come back and we open it for output again. But this time I'd now like to append to a file. All of a sudden F stream becomes valuable, less than IF stream or OF stream. So far so good. So again, in our
I got a question.
Yeah.
So like before, we're opening the file, doing what we need to, and then closing it at the end.
Right.
So now it's necessary to open and close after each modification.
Well, if I want to do something else to it, if you remember back before, I could open a file, read all the data into an array, do a bunch of work with it, so on and so on. But I would still have to close it, and then I would have to open it again to write to it. So I would use ifstream to input the data, store it in an array, manipulate it, close it, and then I'd have to open it again and then write everything from the array back into the file if I chose to do that kind of thing. So yeah, every time you're working with it, you need to open it and close it. If you're going to do
Okay.
something different, you have to repeat the math. Repeat
Very
it.
well.
Back at the end of my, did you have me for 121?
I did virtually.
Yeah. And remember assignment 7.17.2, you had to open the file, go through and read them all in just so you could count how many there were. You closed the file. Then you were supposed to declare an array of that size. So that number 1403 or whatever it was, wasn't supposed to be there. You know, you didn't know what it was you had. But anyhow, after you closed it, you initialized the array to that size. Then you reopened it and read them all in and stored them.
Yes.
Yeah, so exact same kind of deal. Yep. Okay. So far, so good. All right. Boom, boom, boom. Okay. So we just looked at that example. Things that are also going on in files now that become really nice. And I'm having camera issues today, right there. Okay. Input or outputting to the file. One of the things we can do, and this is in section 12.2, is we see examples of file formatting. You know, I'd like to print out a nice report and I could set my precision to 3 decimal places. I could set the width in each, you know, to set up fields so that it goes in groups of 8 and it displays nicely across the screen. This I did a lot of back in college. I had a COBOL class, and that was back when a business department taught COBOL. So we had to learn the common oriented business operating language. And we did a lot of formatting. And that's what COBOL was big with. You know, meanwhile, I'm also learning Fortran over here. And, you know, we're learning a bunch of different things. Now we have one language that can do all of it. You know, or Java can do all of this. So we didn't have to invent different languages for different things. Fortran was mainly for engineers. It was the real mathy one. You know, COBOL was for more displaying, more number manipulation that way. So yeah, we had examples that we were able to, in this case, get our data to print and look nicer in our output file. Okay. Questions? Running over this. Here was an example. I don't know, I don't remember if you typed in 12.3 or not. I don't have it listed that you typed it in, but I'm typing in, let's see, I print out a number, I set precision to 4, 8, 1, 6, 4, and it looks like it did round up. Then I set precision to 3, 8, 1, 6, precision to 2, 8, 2, precision to 1, just 8. So that, again, set precision helped me out with formatting how many decimal places that I wanted. Over here, you can see where the set width comes into play. Okay. So for this one, I do a set width of 8 right here, so that when I print out the number, it goes into a column of let's say I do 3 at a time, 3 rows, 3 columns. But each time I set the width to 8. Keep that in mind. All right. I've been able to pass everything. And you know, at this point, we've been able to pass everything. If I want to call it, show contents, I pass in the name of the file. When I receive it, I have my data type with a reference variable. So it's a matter of keeping, when am I using the ampersand? When do I not use the ampersand? I know last week, the one program, we were having a little trouble. People were not sure putting the ampersand in will work or it wasn't. I think, Nathan, you had questions on that. Is that right?
I don't remember.
Okay, no, that's fine. Okay. So I have void show contents, fstream, and I'm passing in a reference. Another example, I might pass in the file. and I might pass in a string as well. Code listing 12.5 was one you typed in. So you should have seen this example up in my prototypes. I'm going to open a file. I want to show the contents. Here's the name of the file. Here's a string being passed in as well. So when I came into the method over here, I brought in the file and a string. I was able to, the string was the name of the file. So I opened the file up, da 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 da. Again, hard to memorize, but you need to be able to know when I can go back and reference that information. Reading from the file. When I read from a file, I want to be able to read in an entire line. Okay, get line. I want to read the entire line. Now, sometimes I only want to read in certain things. And if I put this up and I read in a string, you know, what's the delimiter that it's going to find? It's going to go until it sees a space or a /n. And so it's going to go and only read in certain pieces at a time. So in order to avoid that, I would do a get line to be able to read in the whole line. I know you did type it. Get my notes out of here. They're in my way. It's one of those days, folks. If I come in and I see the get line, I want to be able to read it in. Read the data file in, the string, and I want to read it till the /n. What did that mean if I was going to read it till the /n? That way I knew it was the end of the line. Or Nathan, you got it, right?
It means read it till you reach a new line.
Right,
basically.
and stored in string. This was called a what? Did anybody pick up the name of what that was?
An escaped character?
Yeah, that's part of my escape sequence, the /n. But this guy right here is actually called a delimiter. And I can set my data file up and say, read in a string until I get to blanks. I could read in until I get to the number 6. I can read in, I could set that delimiter to be whatever I want. For our purposes, and 99.5% of the time, you would want to be able to read it until you reach a /n. Here's some goofy contents down here. What if I made my delimiter a $? Jane Murphy $. So if I did a next line and made the $, my delimiter, it would read Jane Murphy in as the first person, and so on and so on. But like I said, we're going to use the /n most of the time to make that work. Something else not to forget, that was if I wanted to be able to read in an entire line at a time. What if I want to take a file and I get it ready for input and I want to get it a character at a time? Oh, there's a big old pink asterisk on this guy. I want to read it in a character at a time. I could do file.get, stored in ch. Okay, here's an example of reading it in a file at a time. Any questions? Any questions? Lots of simple things there, but what I now need you to do is be able to practice this. So actually putting it into play is what we need to do. Last class, I just lectured the whole time. They were exhausted. They wanted to do some code. You probably want more lecture, less code, but that's where we are. I want you to write a program. How many are here right now? It looks like 16 are here. So somebody came late. I'll find out who. I want you to write a program. I want you to go and find Sonnet 18. What is Sonnet 18? Somebody Google that yet?
Wasn't that in one of our review programs?
Maybe. Sonnet 18 was. Let me hear that first line.
Is it a poem containing 18 lines?
No? Somebody have it? Yeah, it's by Shakespeare.
Does it start with the shall I compare these to a summer's day?
Yeah, yeah. So what I want you to do is I want you to take all of those characters from that file, cut and paste it, make a data file. Once you have a data file, I want you to count the number of each letter and then sort that count descending. So you're going to tell me coming out of that sonnet 18, there are blank, whatever the most letter is, then there's so many of the second most letter and on and on and on. All right, so now at this point, I know that it's best for me to go and write something down. How about 4 score and 7 years ago? So if I was just doing that as my test data, and I started with A's, there is 1, 2, 3 A's. If I counted B's, no B's. C's, I counted C's. There's 1 C. D, 4 score. There's a D. There's 1. E, 1, 2, 3, 4. E, F. I think there's only 1 F. G. There's a G. H. No H's. I. No I's. This would not be a good for the game. Sorry. J. K. L. 4 score and 7 years. M. There are no M's. N. Wow, there's an N. There's an N. 2 N's. O. 1, 2, 3. P. Got the idea what's going on? So you notice how I went through and I'm counting. So, again, I could have gone F, clicked 1 for F. O, checked 1 for O. That would probably be more appropriate for us. But now when I'm done, I need to display, let's see, E, 4, A, 3, O, 3, N, 2, and so on. So I want the letter count of each letter out of sonnet 18. I want you to make a data file, put the sonnet in, go through and do counts, then do sorts. Sound easy?